Hey everyone, good morning and welcome to another First Data Science Community Meetup. Today we have Ilya and Adi from the research team from Israel, and they are working on this project called Cloud Cost Optimizer. And I'm going to leave it up to them to explain it further. So if you guys have no further questions, we can go ahead and get started with the presentation.
Thank you, Akanksha, for the introduction. So I believe let us start with the outline and the main message behind this presentation. The next slide, please. So myself and Adi represent here the Red Hat Research and Innovation Group. And today we are going to present one of our ongoing projects, which is in the area of cloud cost optimization. And then consequently, it is called Cloud Cost Optimizer, or CCO for short. We probably need some kind of fancy name for that project. So any ideas will be appreciated. Next slide, please. So in a nutshell, the Red Hat research team is tasked with establishing and leading research collaborations with all kinds of research institutions and universities. These projects span a wide range of topics and areas, which are, of course, relevant to Red Hat products and what we're doing. This ranges from operating systems, distributed systems, networking, storage, software development, and so on, and of course, the entire world of the cloud computing. And so the goal of this project we're going to talk about today, next slide, please, is on solving the following problem. So you have an application and you want to deploy it on the cloud while paying as little as you possibly can, right? Or alternatively, you have some fixed budget and you want to get as much as possible for this fixed budget. And of course, this is a question worth pursuing. And the question is, how do we achieve that? Now, while there are many avenues to explore for achieving this this result, let's look at the one that we targeted in this project. Next slide. So, well, when you deploy a workload on the cloud, it is kind of similar to the way you are buying a car or a house or any other thing. So you have some kind of a list of requirements and you're looking for the cheapest alternative that fulfills all the entire requirements that you have, right? So similarly here, you have some list of the resources your application needs. Some certain number of CPUs, amount of memory, storage, networking, and so on and so on. And given all these requirements, you want to allocate your application components onto cloud VMs. So that the VMs are as cheap as possible, but still large enough to contain your application. And to get an illustration of that, let's take a look at a very simple example. The next slide is the demo slide, so I will hand it over now to Adi to show us a small demo. And in this demo, you are going to see a really simple case where we have a kind of a hello world application, which is really simple and requires only a single cloud instance, a single VM to run. And let's take a look and gain a feeling of what does it mean to optimize the deployment of such a simple application. Go on, Adi.
Thanks, Ilya, and hi everybody. My name is Adi, and I'm very glad and excited to be here with you today. I will demonstrate our CCO with a simple example. But before I will do that, it's important to say that the demo you're about to see works with real-time data, so you can verify the results if you want. Okay, let's assume that I want to launch an instance to support my app. But how do I really know which instance suits my requirements the best? Or if I already use an instance, how would I know that it is the cheapest one available? So with the optimizer, we can we can find the best instance for us. For example, let's say that my app needs at least 6 CPUs and minimum of 8 gigabytes. We're working with Linux. It doesn't really matter which pricing option we're choosing. And there are a lot of other optional parameters here, such as a region that we can choose, such as a specific instance category, and so on. But let's stick for now with these basic parameters and analyze the results. Okay, what you get to see here is a list of results sorted by the price of the instances. And according to our optimizer, we can see that A1 2 extra large is the cheapest instance that fits our requirements the best. The second one is the T4G 2 extra large, and it goes on. The third instance, we can see that it is the same one as the best results. So what is the difference, except of the price, of course? We can see that the difference is the region. Okay, where one instance is from US East 2, and the third one is from AP South 1. So currently we can see that the same instance is cheaper in one region than other region, and it might change according to the time of the day, of course. That's it for now. Back to you, Ilya.
Thanks. So what you have seen here is a fairly simple example of a simple application that only requires one instance. So I mean, it doesn't make sense to have a research project around this simple example, right? Because what you have to do to find the cheapest option that fits your memory and CPU requirements is just to fetch the table of all costs from the AWS official website, or use their API, which we are doing, and that's it, and pick the cheapest option. I mean, sort this table in Excel or something. But then it comes to the really complex real life cases. So in real life, our applications are arbitrarily complex, which means that we have many different components. These components have non-trivial connections and dependencies. So some components must sit on the same instance, must share an instance. On the other hand, other components maybe are prohibited from sharing an instance, the so-called affinity and anti-affinity. Now, when you have a multi-component application, let's say that your application has 100 components, and not just running the same calculation 100 times and putting each component on a separate instance, because then you are going to end up spending a lot of money for resources that you don't really need. So you have to consider all the possible sharings, all the possibilities of sharing an instance between 2 components, 3 components, and so on. So this grows exponentially rather fast, and soon you end up with spending a lot of time and resources on brute forcing through all the options. So this solution is just not going to work. Similarly, in addition to the instance type, we have a lot of other parameters to take into consideration. So for example, the region, as you saw from this first demo, region plays an important role. And whether you would like a spot instance or on demand, I will touch on that later on. And more and more. And finally, we are not constrained to only AWS. There is Google Cloud and IBM Cloud and Azure, of course, and Oracle. So there are multiple cloud providers. And if we are to consider all the possible alternatives of putting your entire workload on one particular provider, or maybe distributing your workload between on-premise and the public cloud, or multiple public clouds, you end up with a hyper-exponential number of possibilities, which are just not realistic to go through with a simple, let's say, naive solution. To add to that, we are living in a highly dynamic environment. So let's say that you invested this resource and you calculated and you found the optimal location of your application But then prices tend to change on a weekly, sometimes daily basis, and new instance types can appear and old instance types may become deprecated. So we have seen it with actual teams within Reddit, that you think that your allocation is the best until it isn't anymore. So we need this tool to run continuously in the background and keep doing this calculation over and over again and validating it against the newest, the up-to-date information. Now, in the real life, it is not only about the monetary cost optimization, so you do not only want to pay as little as possible, but there are also other considerations that come into play. So, for example, reliability. You could deploy your entire workload over spot instances, which are the unreliable instances that are cheaper but can be taken away at any moment. And then you save a lot of money, but your workload becomes unreliable. So maybe you want to threshold on that. You want to have some kind of a trade-off between reliability and cost, and maybe also the performance guarantees and so on. So this is a multi-objective optimization problem. So to sum that up, next slide, please. We cannot deploy a brute force solution due to the exponential complexity of the entire thing. And the research project around the cloud cost optimizer focused on finding a good solution to take all the variables that I mentioned into account and provide a good result, not necessarily the optimal result, but a fairly good result within reasonable time. And so I will not go into detail on the algorithm that we eventually used. Next slide, please. I will just notice that it is based on advanced metaheuristics. It is some kind of a variation of local search, middle ground between simulated annealing and taboo search. With a few specially crafted heuristics for this problem. And unfortunately, at the moment, we don't have any graphs in the presentation, but we were able to achieve pretty good results for fairly large applications that we simulated. And now let's look at the cloud cost optimizer in action. So Adi is going to show you a second demo, which is about allocating a complex multi-component application, still very simple, of course, for the purpose of the demo, but not single component, but rather multi-component, and walk you through the way things work. Please go ahead, Adi.
Okay, so as Ilya just mentioned, the world is much complex than what you just saw in the first demo. Nobody really launches only one app and one instance in real life. So let's check out the next scenario, which is more a common workload. I've already inserted the input to save us some time, but let's understand what we see here. Okay, we've got 3 apps. Okay, let's split them into front-end, back-end, and DB. And each one of them consists of number of components with different needs. Let's look at the backend. The backend has 2 components. The first one needs 16 CPU and 64 gigabyte. The second one needs 2 and 2, and it goes on. Okay, now let's run the optimizer only on AWS and see the results. Once again, I'm not choosing any region because we would like to see the results on all of the regions. Okay, so what do we see here? According to the best option, we should launch 4 instances of different types, actually 3 of different types, and 2 4G small 2 times. And according to the second best configuration, we should launch 5 instances. And according to the third one, we should launch only 3, and it goes on. Okay, we can also run the same workload on a different cloud provider. In this case, we can run it on Azure. And as you can see, we are getting different results. In this case, even much cheaper than AWS. So with the CCO, you can also compare between different workloads on multiple cloud providers. Currently only with AWS and Azure, but it is pretty easy to support any other cloud provider. Another great option that we have is to look for the best configuration over hybrid cloud providers. In this case, hold on a second. In this case, we can see that the first option consists several instances, 3 from AWS, as you can see here, 3 instances from AWS and 2 instances from Azure, and the price is much better than only AWS or only Azure, of course. And that's it. As you can see, we've got different results with different costs and different combinations of instances. At the bottom line, the CCO finds us the cheapest combination of instances, which meets all our requirements. That's it. Thanks, everyone. Back to you, Ilya.
Thank you. Just one quick note on the demo before we get back to the presentation. Of course, some of you might be wondering, but when we deploy a workload over multiple clouds, how can you ignore the inter-cloud traffic and the cost that we are going to pay for, allocating workload across different cloud providers? And yeah, that's a good question. This is something that we, first of all, we are going to support it in a future version. And second, we believe that in the long term, these hybrid workloads could become a reality and a viable option. And so our tool could play a role into efficiently calculating the best possible allocation over multiple cloud providers. Now let's get back to the presentation. And yeah, another thought that, another thing that some of you could have thought is, wait, so we're at the Operate First meetup. So why are we not discussing something related to data science or things that, kind of talks that we typically have here? And so the answer is that the entire data science part is actually concentrated in our ongoing and future work efforts. Next slide, please. So we envision the CCO not as a standalone product, but rather as a part of a kind of a toolkit for cloud analysis. So as you remember from the demo, it is an optimization tool that simply accepts a lot of inputs from the client, from the user, and assumes them to be correct. Most importantly, we get from the user the precise details on the resource requirements, so how many CPUs and how much memory and so on. It is not reasonable, of course, in general case to expect the user to know that, and that's why we have a separate project called UpLearner, which is about learning application resource consumption on the fly and forecasting ahead of time. So what would be the trends of resource usage for your application, for your different components, and how can you project that into the future and allocate sufficient amount of resources ahead of time. That's one thing we're currently investing into. Another initiative we're working on is about forecasting the prices. So as I mentioned earlier, cloud prices tend to change. And so as of now, we just run our CCO as a batch job, basically, so it can monitor and reactively address the changes in the prices. But we also want to be able to proactively know more or less what the prices are going to be. I mentioned spot instances previously. So with spot instance, of course, there is a question of reliability, and there are works in the academic literature about predicting the interruption rate of different spot instances. We believe that we can leverage the recent work and maybe expand it to be able to predict what is the reliability level of our spot instance assignment. And finally, while our Metahuristic algorithm works reasonably well for anything between 20 and 100 components, of course, we expect its performance and also its quality to degrade as we go to even larger workloads, and then we will need a better solution. So one initiative that we are currently considering is about developing a reinforcement learning algorithm to replace the meta-heuristic algorithm and then achieve even better performance and even better approximation of the optimal allocation. And with that, I think we're done with the talk. And of course, here is the link to the official repo of the project, as well as our emails. So please feel free to reach out for any questions, considerations, suggestions, either to myself or Adi or Aidan, who is our manager in the research team. And we'll be happy to accept questions. Thank you. And I think that we have already answered the question from David in the chat. Yeah, regarding the optimization algorithm, so actually as we speak, we are working on filling in the detail on the optimization algorithm, so all the documentation and how it works and what it requires. So we expect it to be ready, I believe, within 2 weeks. Is that correct, Adi?
Yes, exactly 2 weeks.
So it's going to be available soon. Will they also put new instances when they become available? Thanks for the question, Nassim. So Cloud Cost Optimizer is merely an advisor. So it doesn't go and allocate your resources by itself. But of course, you can plug it into your pipeline to do just that. So we have a user interface, as you have seen, a graphic user interface, as well as an API. It can be run with an API as a script. And then it just calculates the allocation and tells you what it thinks should be the allocation, and then you are free to implement the actual operation against the cloud provider as you wish, as you see fit. Any more questions, guys? All right, so I will just say it again that we'll be happy to get more questions, use cases, thoughts, comments, and so on anytime you wish. So please feel free to contact us. And Akanksha and Michael, thanks for the opportunity to present here.
Thank you instead for signing up for this. It was a great presentation, and we look forward to connect with you further on this project. And anybody has any questions, please feel free to contact us or Ilya, Adi, and feel free to even raise issues on the repo. And if you guys have no further questions, we can say goodbye and see you in next 2 weeks. Thank you.
Thank you. Bye.
Thank you. Bye. Bye. Thank you very much.